Here we have a problem on velocity and acceleration. Okay, let's go over the information. The distance x meters described by a car in time t seconds is given by x equals to 3t cube negative 2 t square positive 4t negative 1. Determine the velocity and acceleration when t is equal to 0 and t is equal to 1.5 seconds. Okay, so first let's find the velocity and acceleration. Once we get the velocity and acceleration, then we can plug in the time, the given times, that is t is equal to 0 and t is equal to 1.5. Okay, here, so to get velocity, what I need to do is I have to find the derivative of the distance x with respect to time. So velocity v equals to dx over dt, that is derivative of x with respect to time. So v equals to d of, and for x we have 3t cube negative 2t square positive 4t negative 1. We can plug in that one for x over here, then we get 3t cube negative 2t square positive 4t negative 1 over dt. Okay, now we have to find the derivative of this expression with respect to t. So here v equals to, so here 3 is a constant multiplied by the variable. So when I find derivative, if a constant is multiplied by the variable, I have to keep the constant as it is and find the derivative of the variable part. So the derivative of t cube with respect to t is 3t square. And here the constant negative 2 is multiplied by the variable. Let's keep the constant negative 2 as it is. When I find the derivative of this t square with respect to t, it will be 2t. And here the constant 4 is multiplied by the variable. Let's keep the constant as it is. The derivative of t with respect to t is just 1. And negative 1 is a constant, so it will become 0. The derivative of any constant is 0. Okay, let's simplify this one. 3 times t is 9t square. Negative 2 times t is 4t positive 4. Okay, now I got the velocity. Okay, now let's find the acceleration. Okay, acceleration a equals to find acceleration, what I need to do is I have to find the derivative of velocity with respect to time, that is dv over dt. So a equals to, whenever I want to find acceleration, what I need to do is I have to find the derivative of the velocity with respect to time. So already we know the velocity, that is 9t square negative 4t positive 4. So we can plug in this stuff for v over here. So I get d of 9t square negative 4t positive 4 over dt. Okay, acceleration a equals to, so the derivative of 9t square means we have to keep 9 as it is. The derivative of t square is 2t, and negative 4 times the derivative of t is just 1, positive the derivative of this constant is 0. So a equals to 18t negative 4. This is the acceleration. Okay, now I got the velocity and acceleration in terms of time t. Okay, here we have a question. What is the unit we have to give for velocity, and what unit do we have to give for acceleration? Okay, let's look at the derivative part of the velocity. So to get velocity, what we do is we find derivative of the distance x with respect to time. So we have x in numerator over here, t in denominator. What is the unit of x? Meters. It is given in the question itself. What is the unit of t? That is seconds. That's also given in the question itself. So we have meters in numerator, seconds in denominator. So the unit of velocity is going to be meter per second. Okay, now we have a question about the unit we have to give for acceleration. Okay, so let's go over the derivative part of the acceleration. Already we know that velocity equals to dx over dt. Okay, to get acceleration, what do we have to do? We have to find the derivative of the velocity with respect to time. Okay, now let's find derivative on both sides with respect to time. So we get d over dt of velocity equals to d over dt of dx over dt. So here we have derivative of velocity with respect to time. That's nothing but acceleration. Okay, here on the right side, already here dx represents the derivative of x. That is, already we got the derivative of this of the distance x. Again we find derivative. So for x we find derivative 2 times. One time is here, the second time is here. So we find a derivative of x 2 times. So we have to put square for dx. So this d square x is, so we find derivative of this stuff x twice. That's why we put square for d. Okay, first time in this one, when I find the derivative of x for the first time, I do it with respect to time. When I do derivative second time, I do it with respect to time. So both the times I do derivative with respect to the times. So I have to put t square. T square means, so here we are doing derivative two times. So both the times we have done derivative with respect to time. So here, look at here, we have x in numerator, the unit of x is meters, and here we have t square. The unit of t is seconds, but t square, so it has to be second square. So the unit of acceleration is going to be meter per second square. Okay, now we got the velocity and acceleration in terms of t, and also we got the units for velocity and acceleration. Now we have to find the velocity and acceleration at t is equal to 0 and t is equal to 1.5 seconds. Okay, let me do it on the next page. Here we have both velocity and acceleration in terms of time t seconds, but our aim is to find the velocity and acceleration at time t is equal to 0. That is, we have to plug in t is equal to 0 over here to find the velocity and here to get the acceleration. Okay, let me do this. So v equals to 9 times 0 square negative 4 times 0 positive 4. So v equals to, this part will become 0, this part will become 0, we just get 4 velocity. Already we got the unit for velocity, that is meter per second. Okay, now let's plug in t is equal to 0 over here to get the acceleration at time t is equal to 0. So a equals to 18 times 0 negative 4. So 18 times 0 is 0, 0 negative 4 is negative 4. And the unit of the acceleration is meter per second square. Okay, now I got the velocity and acceleration at time t is equal to 0. So here the velocity 4 meter per second can also be called as initial velocity, and this acceleration negative 4 can also be called as initial acceleration, because we find this velocity 4 meter per second and acceleration negative 4 meter per second square at time t equals to 0. So whenever I find velocity at time t is equal to 0, that is initial velocity, and the acceleration I find at time t is equal to 0, that's initial acceleration. Okay, now let's find the velocity and acceleration at t is equal to 1.5 seconds. So let's plug in t is equal to 1.5 seconds over here and here to get the velocity and acceleration. Okay, so v equals to 9 times 1.5 the whole square negative 4 times 1.5 positive 4. So v equals to 9 times 1.5 the whole square is equal to 2.25. Negative 4 times, so 1.5 will be 6 positive 4, and v equals to 9 times 2.25 will be 20.25. When I combine these two values, it will be negative 2. So finally, I'm getting velocity is equal to 18.25 meter per second. So the velocity at t is equal to 1.5 seconds is 18.25 meter per second. Okay, let's find the acceleration at t is equal to 1.5 seconds. So a equals to 18 times 1.5 negative 4. That is, we have to plug in 1.5 for t over here. So a equals to 18 times 1.5 will be 27 negative 4. So a equals to 27 negative 4 will be 23. So the unit of the acceleration is meter per second square. So at time t equals to 1.5 seconds, the acceleration is 23 meter per second square.